Welcome back. We're in lesson 5, word problems, yay, and fractional parts of a number. Word problems that contain one statement of equality can usually be solved by writing one equation and using an unknown or variable. Word problems that contain two statements of equality can usually be solved by writing two equations, and so on and so on. In addition, or in general, to obtain a unique solution, the number of equations must equal or exceed the number of unknowns. If the number of equations exceeds the number of unknowns, at least one of the equations is redundant. We know that redundant means repetitive or unnecessary. So if the equation tells us how much two quantities differ, then one of the quantities must be increased or decreased as required so that a statement of equality can be written. And if all that confused you, let's do an example problem. Let's start with 5.1. Twice a number is decreased by 7. I'll tell you, let me type this out for you. I think that might be a little bit better for everybody, especially since my handwriting isn't great on this tablet. And it will help you to see it the way you're going to see it on a test. Just read along as I type to yourself. Make sure I spelled everything right. All right, very good. All right, so there's 5.1. I think next time I'll pause and type it and then let it pop up for you because that'll save us some time. All right, so twice a number is decreased by 7. All right, so that tells me right away we have twice a number is decreased by 7. Decreased is minus. 2 times a number, that's twice a number, is decreased by 7. So there's that statement. And this quantity is multiplied by 3. All right? That quantity, this whole expression, is multiplied by 3. The result, when we see the result, or the result is, that's a clear indicator of the equal sign. All right, now the rest of the problem, the result is 9 less, that means you're going to subtract 9 from something, right? Then 10 times the number. What is the number? So 9 less than 10 times the number. So that means you got 10 times the number, and we're going to subtract 9 from that. Okay, so let's review. Twice a number, that's this, decreased by 7, that's this. This quantity, the whole thing, so you put it in parentheses, is multiplied by 3. Here's our 3. The result, that's the equal sign, is 9 less than 10 times the number. So I think we got that written out right, okay? Now we can solve for n, which is the number. And I like to use n for number just because it's the first letter of the word. It just makes sense to me. So let's distribute. 3 times 2n is 6n. 3 times negative 7 is negative 21. Now we can change signs, or change sides, change signs. So that's going to be there we go. So we changed the side of this. It's positive here, so it'll be negative here. It's negative here, so it'll be positive here. Okay? So now we can simplify. 21 minus 9 is 12. Now we can divide. All right, so the number is -3. Let's check and make sure that we did this correctly. All we have to do is sub in the value of n. So 3 and then so that's going to be -6 minus 7. That's going to be -13. That's -30, right? So 3 times -13 is -39. -39. Both sides are the same answer, so n equals -3 is true. That's correct. All right, so we see kind of how to write those word problems out. I'm going to clear the page. If you need to pause and take notes, do so now. And I'm going to move on to 5.2. And I'm going to pause on my side, type it in, and then start back up. You probably won't notice much, but I'm going to do that for you. All right, that was a little bit faster. So let's read the problem. The number of ducks in the pond was doubled when the new flock landed. Okay, so that's 2, we'll call it D, right? Number of ducks. Let's call number of ducks. Let's say it's, let me get my pen back. Let's say it's ND. We'll use a subscripted variable here. And we'll say 2ND because the number of ducks was doubled when the new flock landed. Then 7 more ducks came. So plus 7. The resulting number, the result, that means equals. The resulting number of ducks was 13 less than the original, 3 times the original number. So it was 13 less, so that's minus 13, than 3 times the original number. So that would be 3 times the number of ducks. All right, so let's look at how we can solve this. We can take this and swap it over, and we could take this and swap it over. So that's going to be 7, and we're going to swap the sign here. And then we're going to swap the sign here. So that's going to be 20 equals the number of ducks. So let's put that back in to our original equation. So 2 times 20 plus 7 equals 3 times 20 minus 13. 40 plus 7 equals 60 minus 13. 47 equals 47. So this is correct. So this is correct. We know we found the right number. So the hard part is this right here. This whole thing. This is the hard part. If we can read it correctly and understand how to put together our word problem, then we can solve it. You know, this is the hard part. The number of ducks. Find the variable you want to use for number of ducks, and we're using the subscripted variable, was doubled. Doubled means twice when the new flock landed. Then 7 more came. So 7 more. We add 7. The resulting, that's always your equal sign. The result, or this is, that's equal. The number of ducks was 13 less. So it's going to be your minus 13 than, this is tells you what you're subtracting it from, 3 times the original number. And number of ducks was the original number. Okay, so if you can get that from here, then you are doing well. All right. Notice we use the change sides, change signs, and it went a little bit faster. So if you like that method, go ahead and jump on it. You can always still use the plus. It's entirely up to you. Plus and minus is the same difference. It's the same thing that we did. All right. Let's look and see what else we have. We have one more example of word problem to do. And I'm going to do the same thing I did before, and I'm going to clear the page. So pause if you need to take notes. And we're going to do 5.3. So I'm going to pause and type it out for you, and then you should just see it appear. Okay? All right, my students, our problem states the sum of -7 and 6 times a number is multiplied by 5. So let's write that out. Let's see what we got. So the important stuff here is the sum of -7 and 6 times a number. So that's going to be 6 times the number minus 7. All right, then we can say it's multiplied by 5. So that's going to be times 5 right there. All right, so that's that. All right, now we have the result is, that's our equal sign. Okay. Now we have 332 less than 3 times the number. So we know we're going to subtract 332 because it's less from this. So we have 3 times the number minus 332. What is the number? So now we can solve it. First, we're going to distribute. Actually, let's go ahead and I'm going to pause and let you pause and solve this problem and then see what you get. All right, if you got an x equals -11, then you are correct. If you did not get x equals -11, follow along and let's see where you messed up. 5 times 6x is 30x. 5 times -7 is -35. And then we just brought this down. It was already up here. Now we're going to change sides, change signs. So we brought 3x over here and made it a -3x. We brought 35 over here and made it a positive 35. We combined these numbers on both sides to give us 27x equals -297. We divided both sides by 27 and got x equals -11. And that's where you should be. And that is the correct answer. All right, moving on to 5B. All right, let's clear the page. Pause if you need to. All right, moving on to fractional parts of a number. These are word problems that use fractions in them. Okay, fairly straightforward. Let's do 5.4. All right, here's our problem. 1/5 of the clowns had red noses. If 30 clowns had red noses, how many clowns were there in all? And I typed that. I needed a space there. That's okay, you get the idea. So 1/5 of the clowns had red noses. All right. If there were 30 clowns with red noses, how many were there total? So let's think about that. 1/5 equals 30, right? What we don't know is how many there were in total. So in order to find what that is, we're going to put 30 over x. because 30 represents the one part of 5. The whole part, the 5, we don't know what that is. We don't know. So we're going to do some quick cross multiplication and figure out. So we have 1 times x, that's x, and 5 times 30, that's going to be 150. So there's a total of 150. That's pretty easy to figure out. All right, so we know that 1/5, and we could check that. All we have to do is divide 150 by 5 to get 1/5, right? So let's do that. If we divide 150 by 5, the answer is going to be 30, right? Because 15 divided by 5 is 3. So that's pretty straightforward. We know we got the right answer. The total number of clowns was 150. So these are pretty straightforward. These are going to be, for the most part, cross multiplication problems. Let's do another one. Let's do 5.5. All right, so here's our problem, or a question, I should say. All right, so Miss Tracy can't spell. We have 7/8 of the Tartar horde rode horses. Okay, there should be an H there. I can't spell today. If 140,000 were in the horde, how many did not ride horses? Okay, first of all, know what your question is asking. It wants to know how many did not ride horses. So you want to look at this part again. If 7/8 did ride horses, we're asking how many did not ride. So if 7/8 did, then that means that 1/8 did not. Okay. Now it says if 140,000 were in the horde, we know how many we have in total, but we don't know how many did not. This is how many did not. 1/8 of 140,000. So we know the total amount is 140,000. So how many, this 1 out of 8 is the number we're looking for. This is our x. It's how many out of 140,000 is represented by 1/8. So the easy thing to do is we cross multiply 1 times 140,000. That's 140,000. And then we have 8 times x, which means we divide both sides by 8. And that's going to give us 17,500 equals x. So this is how many did not ride horses. And we got that because we said, okay, if the entire horde is represented by 8 out of 8, that's all of them. And 7/8 rode horses. We are not concerned about that 7/8. We want to know how many did not ride. Well, 1/8 is what's left. So that's how many we're looking for. And that's why we use that fraction to find the number that we're looking for. We used 1/8 because that's how many did not ride. All right? And you can even make little notes. They did, so these didn't. Right? I hope that makes sense, that illustration. You could even draw your little horse if you wanted to. That's a terrible looking horse, I can tell already. It's pitiful. Okay, we won't draw a horse because Miss Tracy can't draw today. I can draw boxes. I can't draw people or animals. That's where it stops. All right, that's all I have for lesson 5. I'll see you guys in lesson 6. This was a pretty good lesson today.